Hi, welcome to the pre-calculus lecture series. And in this video, we're going to do some practice on the chapter 2 test. So just kind of like the review sections for all the topics we cover in the chapter 2 here, okay? So this is the chapter 2 practice test. Okay, so now let's go to our worksheets about the practice test is here. Okay, so for here, okay, so let's start. And the problem number 1, they say, which of the following graphs is a function? If a graph is a function, is it a one-to-one here, right? So the purpose for this test is here, basically it tests you the two concepts here. So the first concept is, we call it the vertical. Okay, so it's a vertical test, all right? So the vertical test, what is the test for? Test is to see this is a functions, right? So that means if you have a line goes through the 2 points of the y, and it is not a functions, right? So we have vertical test. Then the next one, we have a horizontal. So the horizontal test, what do we test for? If this is the one-to-ones, right? So that means if I have a horizontal line, and then if I touch 2 places, then we know the, the 2x value will give the same y value, then it is not, it is not a one-to-one. So let's do here first here. You need to pass the vertical test first, right? Before, if it's a function, then we test a one-to-one. So like this one's here. So if you say, hey, this is one-to-ones here, and so what you do here, you say, okay, so if I, do any vertical lines here, well, seems all the vertical lines here only touch the function at what? At one point, right? So we say, yes, this is a functions, right? Okay, after it's a function, then you say, okay, let me do the horizontal line test here. So the horizontal line, that means, do I touch the 2 places? So this is, you put any like line here. So every line you only touch what? Touch 1. So this is a what? Is a yes. This is a one-to-ones, right? So this one satisfies both here. So one-to-one. Okay, so now let's take a look at the second ones here. The second ones here, let's see, so this is the function. So you put the vertical lines here. Yeah, seems like every vertical line is only touch 1 point, right? So we say, yes, this is a function, right? So this is a function. Okay, after that, now if it's a function, then we say, okay, let's test to see if this is one-to-one or not. So in order to do the one-to-one, so we say, okay, let's do the horizontal line. So this is here, those two looks okay. Hey, but in here, what you see here, you touch the graph at the what? At the 2 points, right? It's more than 1 point, so it's 2 points. That means both of those x value will give the same y value. If 2 of the values give one same value, so this is one-to-one, so we say no. This is a function, but it's not a one-to-one. So we say no, it's not a one-to-one, right? It's no one-to-one. It's not a one-to-one here. Okay, because this line touched both touch the graph in the 2 places here. Okay, so now let's take a look at this ones here. The C, we say, is this is function? Let's do some vertical line test. Oh boy, so they touch the 2 places. So we say no, not functions, right? It's not a functions here. If it's not a function, of course, it's not one-to-one, because the one-to-one has to be, the defined in your functions, right? So this is not a one-to-one. So this is pretty simple. Okay, so now let's take a look at the last ones here. So do the vertical line test first. Oh boy, I got the 2 places here. So we say it's no, right? So this is not a function. And so if it's not a function, automatically is what? It's not, it's no, it's not a one-to-one. Right? Okay. And so that's it for the problem number 1. It's pretty simple. So basically, they test the concept about the vertical line test and what, right? So be careful. So this is a key concept we try to test. It's vertical line test and the horizontal line test, right? Okay, let's take a look at the problem number 2 here. So the problem number 2 is here, right? So the key concept, the problem number 2, we try to test has 2 here. So first thing is try to find the domain, right? And then the other things here we want to find, we call this the average rate of the change. So those are the 2 concepts we want to do. Okay, so let's take a look here, right? So f of 0, that means you plug the 0 in here. So the f of 0, let's see what is f of 0. So this will be square root of the 0, 0 plus 1. So it's 1 over 0. What is here is 0. Okay, how about f of 2 here? F of 2, so that means the square root of the 2, 2 plus 1. So what is the answer? Square root of the 2 over what? Over 3. Okay, so now let's take a look at the f of a plus, okay, so f of the a plus 2, f of the a plus 2 is here. That means every x, you need to replace it with what? A plus 2, right? So the a plus 2, what is the answer here? This will be a plus 2 plus 1. Then this is a plus 2 here, correct? So now this will be the a plus 2, and this is a plus 3. Okay, so now let's take a look at the part B, the domains here. We say we start with real number line, then we go to excluded things. The first thing you see here is, hey, you see a denominator. So I know if I see a denominator, so what is the point I need to exclude here is x plus 1 equal to 0, because I know I cannot have zeros, right? So x equal to -1. So this is the point I need to, the exclude out from the, my domains here. Then the next thing here is the square root of x, right? The square root of x. And so the square root of x here, that means everything cannot, everything cannot be what? Negative, right? So I know the x has to be greater than or equal to 0. So this is we want to exclude, so the x cannot be equal to -1. Okay, so let's take a look here. So what is our answers here, right? So here we have 0, this is 1, 2, 3, this is -1, -2, -3, right? So you tell you, say, hey, the x cannot be -1, so this one cannot be -1. The x can be everything, right? So from the denominator, say here, the x can go everything except this one. Then the top ones here, they say x greater than or equal to 0. So that means here, that's the numerator, right? So we said, okay, this is the green one is numerator and the red one is denominator. So the domains here has to be what? Has to be satisfied both, right? So where is the both? So this area is the both, right? So satisfy both region. Okay, so now let's write a domain in the interval form. So will be from where? From 0 to infinity here. All right. So now let's take a look at part C here. They say, what is the average rate of change from 2 to 10? So you say f of the 10 minus f of 2. then divided by 10 minus 2. That is how do we define the average rate, right? So then here, so what is here? So you will have 10 plus 1. So this is 11 square roots of the 10 minus the square roots of the 2 to the 3. What do you divide here? 8, right? So in here, basically, you just need to do a little bit of algebra. So the common denominator is 33. So here, this is 3 times the square root of the 10. Then this is 11 times the square root of the 2 here, right? And now in here, you combine the names. So this is 33, 3 square roots of the 10 minus 11 square roots of the 2 over 8. Then you flip. So what is the final answer? So it's 264, 3 square roots of the 10 minus 11 square roots of the 2. Okay, so that's it. So the remember, for the second problem, what the problem we try to test here, make sure you understand how to find the domain and how to find the average rate of changes here. Okay, all right. So the number 3 is here. We said, hey, find the number, find the net change and the average rate of the changes, right? Okay, so this is the one is in the generals, right? So we want to find the average rate of change from the t equal to 2 plus h and to t2. Okay, so let's try to find the net change first, right? So the net change is just equal to f of the 2 plus h minus f of 2. Okay, so in here, the 2 plus h here, so that means every t here, you need to replace with 2 plus h, right? That's what we did a lot in the chapter 1. Okay, so let's try to do here. So this is 2 plus h square minus 2, the 2 plus h, right? So this is your x value. Then minus f of 2, right? So f of 2, so that means 2 to the square minus 2 times what? 2 times 2 here. Okay, so now this one is easy. We say, hey, this is a 2 square minus, so this one is what? This is zeros, right? Okay, so now let's continue use our algebra. So this is a FOIL. So 2 plus h squared will be 4 plus 4h plus h squared. Then distributive rule minus 4 minus 2h. And these things here is minus zeros, right? So let's see anything we can cancel. So we say, hey, here 4, I can cancel. And then combined, so I have h squared, and 4h minus 2h, how many h here? 2h is here, right? So I can factor the h out, so it's h plus 2. So this is my net change. So the average rate of change, right? So we know the average rate of change is just what? It's just your net change divided by what? Divided by whatever you vary from, right? So it's from the 2 plus h minus 2. So the net change we just calculate is h plus 2. So this one is 2, so here is h half. I can cancel the here, right? So what is the answers here? This is h plus 2, right? All right, so it's pretty easy, right? Okay, let's take a look. Okay, so this one's here, number 4 here, we say we want to scratch the graph. So this is the cube functions. Remember, when we try to do here, we always start with what? Few key points, right? So I hope you still remember what is the key point for the cube functions, right? So here, let's move a little bit here. Okay, so the key point for the cube function, this is x, and this is x cubed, right? Okay. So all right, so this is x cubed, right? Okay, so we say we always choose to start with 0. So this is 0, then we have 1. So this is 1, we have 2. What is here is negative 8. Then we have a negative 1. Now what do we have here? Negative 1, negative 2, negative 8, right? So this is what we call here parent functions, right? So like here, the first things here we try to test us is what is the parent function, and then the main purpose here is the transformations, right? Okay, so let's try to graph the parent function. So in here, okay, so here I have 0, 0 is here, 1, 1 is here, 2, 8 is here, right? Then I have negative 1, negative 1, negative 2, negative 8, right? Negative 2, negative 8. So like we say, because this is not our final function, so I plot it on the what? On the dot lines here. Okay, now let's take a look. We always do the inside parentheses first. So the first transformation we want to do is x minus 1. So we know when we talk about x minus 1, what's that mean? That means we move to what? We move to the place that x minus 1 equal to 0. That means x equal to 1. That means we move on the x-axis to the right 1 unit, right? So let's see here. So this point move over to here. This point move to here. This point move to here, right? So you just move to the every point move to the right 1 unit. So this point move to here, and this point move to here, right? Move 1 unit. And then this one still is what? This one still is a dot 1. The reason why is we still did not, we still have 1 more transformations, right? Okay, so now let's do the next transformation. This transformation is what? It's -2. Okay, so the -2, as we think about, so what is there? So going up or going down? Is going down 2 units, right? Okay, so now let's try to move here. So this one going down, so it's go to this unit. This one going 2 units, going to here, right? Then this one going to 2 units, boom, boom, going to here. Okay, so this one going to 2 is, this one going to 2 is going to 1, 2, so it's going to here. All right, okay. So now this one going to 2 units, going to here. Okay, so now we finish all the transformations. So now this is, we can use the solid line. So this is what our final functions here, okay? So when you try to do it, you just do 1 transformation at a time, right? So remember, you need to get the parent function first, all right? All right, so now the next problems here, this is so what is this one try to test us? This is try to test us how to, the key concept is how to graph piecewise functions, right? So this is try to test us how to graph piecewise function. Okay, so before we graph it, so the first thing is let's take a look, f of -2. So that means I'm finding the value. So what is my x values here? X is equal to -2. So now I need to decide which function I'm using, because -2 is in which domains here? It's in this domain, right? It's less than 1. So I have to use this function, right? So -2 will be 1 minus, and then x equal to -2. So this is 3. All right. Okay, so then if this is f of 1's here, so now this means x equal to 1. So 1 is belong to where? Still belong to here, right? So now you can say, what is here? You will say 1 minus 1 is equal to zeros here. You know, if you want, you know, so how about if I say f of 3? So if you want to find f of the 3, so take a look here. This is the x value is 3. So which domain is 3? Oh, here, that has to be in this domain, right? X greater than 1. So what will be the answer here? This will be 2 times 3 plus 1. So this will be 7 here, right? So that's how do you find the value of the piecewise function. So you need to be careful, like where, you know, is the functions, right? Okay, so that's what we, you know, where is the value you try to find, and which domain it belongs to, then use that function. Okay, so the sketch the graph. So remember, when we sketch the graph, which point you always need to scratch. So you always need to sketch about, okay, so you always need to sketch where we talk about it. That's the key for success, right? So you always has to sketch both of them at this breaking point, right? Okay, let's take a look at the first graph, 1 minus x, right? So here, so this is the x value, this is x1 minus x, right? So this is our first graph here. So we say we always sketch at the breaking point. So I need to sketch at 1. Right, x equal to 1. So what is here? So 1 minus 1 is what is equal to 0. Because this is the, this is the less than. So I choose a couple more points. I can choose 0, right? 0 is less than 1. So what is 1 minus x is 1. If you want, you can choose another point. You can choose, how about any other point? I say, hey, negative 2. So if I choose negative 2, this is 1 minus negative 2. What is here is 3, right? Okay, so now let's try to graph these ones here, right? So if 1 is equal to 0, so x equal to 1, this is equal to 0. So this is a circle or a solid dot? It has to be what? A solid dot, right? Why? It's because, why? It's because it have equal signs here, right? So it doesn't want me to have a solid dot here. Okay. Okay, now we find the next one is 0 and 1. So this is another point. And then negative 2 and 3. So this is another point. So I know this end, what happens here, you will have a what? A lines here, right? Right, so this is have a lines here. So like this lines go from here, this is a solid dot, right? Okay, so now let's take a look at the other ones here, the other function. So this one is x, and here you have 2x plus 1. We say you always need to plot at the break point. So here is 1 again. So this 2 times 1 plus 1 is 3, right? Because it's greater than, let's choose a couple other points. So if I choose 2, so what is the 2 here? So 2 times 2 plus 1 is 5. I choose 3. What is here is 7, right? Okay, now let's graph these ones here. Okay, when x equal to 1, the function equal to 3. So it's 1, 2, 3. But here, I definitely have a what? I definitely have a circles, right? Why I have a circle here is because this is greater than, does not have an equal sign. So it has to be a circle. Okay, and then 2 is 5. So this will be my next point. 3 is equal to 7. So this will be my next point, right? So that's why in here, this end, your graph is going like this. Okay. Okay, so as long as you remember, right, you always need to graph both at the breaking point. So one piece is going to be have a solid, one piece is going to have a the circles there. Okay, so now let's take a look. This is the composite function. So let's say f of x equal to x squared plus x plus 1, gx equal to x minus 3 here. Okay, so f plus g. So let's take a look at the easy ones here. Save some space for the other here, okay? So f plus g, So we say, what is f plus g? You just add them together, right? So it's x squared plus x plus 1 plus x minus 3. What is the answer? So it's x squared plus 2x minus 2, correct? That's pretty easy, right? So B here, f minus g. What is f minus g? So this is x squared plus x plus 1 minus x minus 3, right? Be careful, you put a parenthesis so you don't screw up with negative signs here, right? So this will be equal to the x squared plus x plus 1 minus x, and then what is here? Minus is plus, right? So this will be x squared, then x and x cancels, right? So this one and this one cancel, then 1 and 3 end up with what? Plus 4, right? Okay, so now the next ones here I'm going to do is f compose of g's, right? Okay, so here f compose g, remember the f compose g, that means g is going to the inside, and so that means f, what is gx? Is x minus 3. That means you need to put x minus 3 into the f functions, right? So that means here you will have what? So you will have x minus 3 squared plus x minus 3 plus 1. All right, okay, so that's it. And if you want to simplify, you can simplify it. If you know, or you can just leave like a layer. So either way. Okay, so the here D here. So the G composed of the F here, right? That means the F going to go inside. So that means in here G, what is F here? Is x squared plus x plus 1. That means now for the g function, every x you need to replace with this ones, right? So let's take a look. G function is x minus 3. So this is x squared plus x plus 1 minus 3, right? So this is x minus 3 here. So the answer here is x squared plus x minus 2. Okay, so now let's see the part F here, part E. Part E is here, they say, hey, what is f of G2 here? That means that here this is f of gx, right? So G2, that means that this function, the x equal to what? Is equal to 2, right? So you plug in, so this is 2 minus 3 the square plus 2 minus 3 plus 1. Okay, so so this one will give you 1 here. Now the GF of 2, so let's take a look. This is part F, this is GF of 2. Okay, so for the GF of 2, that means now x is equal to 2. You need to plug into those final functions here, right? So it doesn't have 2 here. Okay, so here. Okay, so now in here you say 2, so it's 2 to the square plus 2 minus 2. So what is the answer? So it's 4. Okay, so now let's take a look. The last ones here is G compose G. Oh, gee whiz, got 3 compose here, right? So G compose G compose G. Well, doesn't matter. So that means it's G, GX. And so you have 3G, so this will be another what? Okay, so this will be G and GX, right? So you compose 3G, so that means you have like 3 here, right? So, okay, now let's do a step by step. As long as you finish, you follow the step by step. So this is G, means G. So what is GX? Is x minus 3. Correct? And then now you need to put every x in the G with x minus 3 here, right? Okay, so then this you will have G. So this is x minus 3 minus 3, right? So this will be G x minus 6. So now you do one more time. So for all the G, now you're going to what? right? So you're going to place with what? Place with x minus 6 again. Okay, so what is the answer here? The answer will be x minus 6 minus 3, so we'll give you x minus 9. Okay, so doesn't matter, it looks scary, G compose G, so just write it out. So that means you're going to have 3 G's here, so you go each one and you place the X with the whatever in there. All right, okay, so now the number 7 is try to find the inverse functions here, right? So we say find the inverse function. The first thing is here, find the inverse function. Yes, we try to, right? So we try to write this one is y equal to x minus 3, 2x plus 5. Then this one's here, you can say it's y over 1. Then this is x minus 3, 2x plus 5. Then what can you do? You can do cross product, right? So you can do the cross product. So let's will give you what is y to the 2x plus 5 equal to the x minus 3. I want to solve for what? I want to solve for x, right? Okay, so now let's just do step by step and you will get it. So this is a distributive property. So this is 2xy plus 5y equal to x minus 3, right? And since I'm solving for x, right? I'm solving for x, so I need to move all the term half x to one side and without x to the other side. All right, so the first thing I say, okay, I move all the things not x, so I say I plus 3 plus 3. Can I? Yeah. So this will be the 2xy plus 5y plus 3, and this is x, right? So now I have this term, 2xy, this term has x, so I minus 2xy, right? So what happens here, this is 5y plus 3, this is equal to x minus 2xy, all right? Because I am going to solve for x's, right? So this is 2y plus 3. So I need to factor the x out. So this is 1 minus 2y. So then what I can do, I divide by 1 minus 2y on both sides, right? So that's why I have the 5y plus 3, 1 minus 2y equal to x. So remember the procedure I told you after you solve for the x, and then what do? You switch, right? So x become y, right? So you switch the x become y, right? And then for the others, and then the y become x here. So this is 5x plus 3, 1 minus 2x. See here, you switch all the y, become the x. And this is your answers here. So this is, we say f inverse x is equal to the 5x plus 3, 1 minus 2x, right? So this problem is how to find the inverse. So what is the process? You set it equal to y, right? Then you solve for x. After you solve for x, you switch x and the y. Okay, it's very important. Like I said, this one, is always very important, special. Like when you go into the calculus, is very important. Okay, so now this one's here, a graph giving. Let's try to see here. So the domains here, this is 1, 2, 3, 4, 5, 6. Right? So this is 1, 2, 3, 4, 5, 6, 7. Okay, so I just mark it. So what is the domains here? Domain is the value of x, right? So here is the domain. So the domain will be what? From 0 to where? From 6, right? So what is the range going to be? Range is the value of the y. Y is from what? 1 to what? 7, right? So both are bracket, right? Okay, so now let's take a look at f of 0. So f of 0, that means when x, so what is the value of x? It's 1, right? So I know the f of 0 equal to 1. Okay, so f of the 4, What is f of 4? So when x equal to 4, what is the y value? Y value is 3, right? Okay, so now let's say, hey, graph f of x minus 2, see here. Okay, so this is x minus 2. So I know this is a horizontal shift, right? So how much I need to shift here? We shift the amount, you make this one equal to 0. So how many units we shift? Hey, we shift to the right, to the positive 2 units, okay? So let's try to graph it. So this point, I shift to here, correct? All right, let me use a different color. So here, so this point, I shift to here. What happened to this point? I shift to 2, 1, 2. I shift to here. This point, I shift to here, right? So now my answer here, so these ones here, you connect. Ooh, I got all right, so hope I can connect better. All right, so here, boom, 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 and here. Right, so this is the green one, is what? Is f of x minus 2. Okay, so now let's take a look at this one's here. So this one's here is fx plus 2. What's that mean? That means shift what? Shift up 2 units, right? Okay, so shift up here. So this one's here, go here, right? So this point shift up to here. This point go up 2 units, go where? Go here, right? And this up, go up 2 units, go here, right? So now you connect it, right? So this is, we say, is f of x, what? Plus 2, okay? And now the next one's here. So those are the graphs, right? So let's say the net change and the average rate change between x equal to 2 and 6, all right? So let's take a look at the net change. So the net change is here. The x equal to 6. 6, what is the x here? Is 7. I'm sorry, the net change doesn't have a, okay, it doesn't have the divide part. Okay, net change is x equal to 6. What is the y here? Is 7. Minus x equal to 2. So what is the x here? Is 2, right? So it's 7 minus 2. So this is 5. Okay, so if this is a net change, so what is the average rate of change? What is the average rate of change? Will be the net change is 5. So 2 to 6 is 6 minus 2 is 4, right? So the average rate of change is 4/5 here. Okay. Now let's take a look at this one. This one's here, I want to find F inverse 1 and F inverse 3. Remember, what is F inverse mean? So remember we say if you have 2 things here, right? So this is the x value, this is the y values here, right? So like from here to here, right? So from here to here, this relation is f of x. That means you give x value, you find a y value. Then what is this relation? So if this is the green one, that means you give the, you give one y value, you want to find the x value. This is what I call this F inverse relation, right? Okay, so now let's take a look. Let's take a look at these ones here. Okay, F inverse 1, what's that mean? That means in here, you give me a 1. I want to see, because I'm go backward, right? I want to see which value will give y equal to 1. So which y value will give y equal to 1? Let's focus on the red lines here, right? So the which one? Is 0, right? So I know the f of inverse 1 is equal to what? Is equal to 0, right? It's because this is the point of x. Right now you go backward, that means I'm finding the x value. Okay, so now this is f inverse 3. That means if you give me a value equal to 3, y equal to 3. So which x value going to give it 3? So you look here, dun, dun, dun. Oh, this is y equal to 3, right? So which value going to give it? It's a 4, right? So that's why I know the F inverse 3 equal to 4. Okay, so this is part is super important. I think other parts you should be able to find it easily. And but this part, you know, is kind of you go backward, right? So the 1 is your y value. So you want to find which x value give you 1. So that is 0. Then the same way, the y value is 3. You want to find which x value will give you is 4. Okay, so the last part here is I say, hey, graph the inverse, all right? So for the graph the inverse, the key concept we use here, the graphing, right? So the graphing, we know the F and the F inverse is what? Is going to be symmetric to what? To y equal to the x lines here, all right? So that means when you do the graph here, so that's why you said, okay, it's going to be symmetric to the y equal to the x line. So what is y equal to the x line? That is the diagonal passing through the origin, right, at 45 degrees. So the y equal to the x, let's try to graph it. So like here, here, 2, 2, then 3, 3, then 4, 4, then 1, 2, 3, 4, 5, 5, 5, and 6, 6 here, right? So it's a line. It's like, okay, so this is the, I hope I can, ooh, good, kind of good, right? So this is the line, this graph supposed to flip over. It's like a symmetric, right? So let's see if we'll be able to graph it, right? So make sure, right? So I'm going to be kind of the symmetric, right? So that's why I put this dot line here. I don't want to, all right? So here, right? Okay, so now let's take a look. So this one, the touched lines are going to be here, right? So this one's here going to reflecting, right? So this is here. So what is this point going to reflecting? If it's symmetric, going to be here. Okay, so that's my first segment I'm going to do. Then this point here, right? So look here. So which point are going to reflect into? We're going to reflect into here. So this red segments here are going to be like that, right? So now you can see it is like what? It is kind of symmetric to the y equal to the x. Okay, now like for this number here, this one is on the line, so it's going to go over here. Then take a look for this one's here, this point, right? So this point, what point are going to reflect into? We're going to reflect into this point, right? Because this is the one, you know, so that's why it's kind of reflecting to here. And this one is touching the dot line, so be here. So what is my graph here? So this is my graph here. All right, right? So this green ones here, this is F inverse. Look here, right? So it's kind of a symmetric to the y equal to the x-axis, right? So this is the part we need to be remember very carefully. It's very important. So F and F inverse, what do? They were symmetric to the y equal to the x-axis. So when you try to graph it, so you put a dot line there for the y equal to the x line, and then you let your graph flip over that line. So remember that symmetric kind of like means like mirror, right? So that means the image, you know, when you try to flip over, they should match, right? So that is the F inverse. Okay, so this is the chapter 2 practice test, and it covers the several very important concepts and the topics in the chapter 2, right? The inverse topic, composite, how do you compose the function, compositions, and function transformation, moving up, moving down, moving right, moving left, right? And how to find the inverse, and how to do the piecewise graph of the functions. And now, of course, how to find the domain range, and what is the vertical line test, and what is the horizontal line test, right? Those are the few key concepts in the chapter 2 here. Okay, that's it. And I hope this help you to review the chapter 2 topics and kind of to refresh your memory about what is the chapter 2 is about. Okay, that's it. And it's nice to talk to you. And looking forward to talk to you when we start the next unit. We're going to talk about the chapter 3 here. Right? All right, that's it. Okay, have a good day and bye.